Hi everyone, welcome back. I am going to finish the rest of the study guide. That is problems 14 through 18. Hopefully it won't be too much longer. Number 14, is -4, -1 a solution to the following system of equations? And our equations are 5x minus 3y equals 23 and 2x plus y equals 7. So there's two ways to go about this problem. You could straight up solve it if you want, but that's going to take a bit more time than the other way that I'm going to suggest. If this solution works, then when you plug the numbers in, this should give you true statements. So let's test that theory. So we have -4 is x and -1 is y. Make sure you plug the numbers into the right places, of course. So we have 5x minus 3y equals 23. 5 times -4 minus 3 times -1 equals 23. 5 times -4, that's -20. -3 times -1, that is actually a +3 equals 23. -20 plus 3 is -17. And clearly -17 does not equal 23. Since it failed the first equation, we can go ahead and say no, this is not a solution, because it must work for both equations in order for it to be a solution. And since it failed the first equation, we can already with confidence say no, it does not. So no is going to be our answer. And we can move on. Number 15, solve the system of equations by the method of your choice. So remember, there are three methods that we're allowed to use. Substitution and elimination are the main two. And the third one is actually graphing. Remember, graphing is a method to solve equations with. This problem is clearly set up with the intention that you were going to solve with elimination. The x and y's are both on the left side of the equations, and our numbers are actually already set up for elimination, like we can eliminate from the beginning. So elimination is going to be the easiest way. You are welcome to graph or use substitution, but I would recommend elimination. So let's take a look at our numbers here. The x's both have a 4, which is great, but one of these needs to be a -4. So let's look at the y's. Both y's have a 3, and on top of that, one of them is negative, the other is positive. So these y's can be canceled right off the bat. So that's what we're going to do. Reminder, we add down. The y's are going to cancel. We have set that, it was already set up that way, so we knew that was going to happen. 4x and 4x is 8x. And then 29 and 35, that's 64. And then to finish solving, we just need to get rid of the 8 on the x, so we'll divide by 8 on both sides. 8's cancel. X is 8. There's half of our answer. To get y, we just pick an equation to plug x into. For me, I'm going to pick the bottom equation. All the numbers are positive. That's typically what I go for. So we have 4x plus 3y equals 35. Plug in 8 for x. Make sure you plug this into the right number. If you plug it in for y, that's going to be detrimental. 4 times 8 plus 3y equals 35. And then we solve. 4 times 8 is 32. Plus 3y equals 35. We need to get the 3y by itself, so we're going to move the 32. This is a minus 32 on both sides. (3y) equals 35 minus 32 is 3. Lastly, we'll divide by 3 on both sides. These 3's cancel, leaving just y. Don't cancel the 3's on the right side because then there will be nothing there. Remember, 3 divided by 3 is just 1. So y is 1. So our final answer, remember, you have to put both of these together as a point, x comma y. So our point is 8 comma 1. Here is our answer. All right, 2 more problems? 3 more. 16 is a very quick problem. State whether the following points are solutions or not. Write yes or no in each blank. So we have 5 points to look at. Let's make it very clear what is a solution on this graph. These are inequalities that are graphed, and then we have the shading, of course. So the shading that is the darkest, so that's this section right here. This is where all the answers, solutions are. So it's everything in the shaded area, the dark shaded area, so this piece, not these two. On top of that, any point on this solid line that is a border of this shaded area, these are solutions. Anything on the dashed line are not solutions because dashed is not included. So let's go through these. A, it's not even in the right shaded region, so no. B, I get a lot of questions on B. B is the intersection of the solid and the dashed line. So because it's also on the dashed line, even though it's on the solid, this one is no, because it doesn't work for the dashed line. That's the problem. C, this is the most obvious way to find a solution, or the most obvious kind of solution, or smack dab inside of that region, so yes. D, on the dashed line, which is not where we want it to be. Dashed line is no. E, solid line that borders the region, yes. (17) I changed this problem from what you have. So if you haven't done this already, if you weren't in class or didn't write it down while we were in class, make sure you make these changes. I believe this was a 6x. I changed it to a 3. And then I changed this 10 over here to an 11. The reason I did that is because the original problem gave very ugly answers. They were not easy to work with. So I went ahead and changed it so you would get nicer answers. But I went ahead and changed it in a way that wouldn't change the answer to part A if you had already done that. Part A. What number would you multiply the second equation by to eliminate the y variable? So this is assuming that we're going to use elimination to solve this problem, which would be the suggested way based on how this is set up. Again, x and y are both on the left side. So what number would you multiply the second equation, the bottom equation, by to eliminate the y variable? So the goal is to get these to cancel. And the top y is a -3. So a positive 3 would cancel it out. So I want 3y on the bottom in order for it to cancel. So all I have to do is multiply the bottom by a 3 to make that a 3y. Because remember, this is just a 1 here, and 1 is very easy to manipulate. You can change it into anything you want. So if I want it to be a 3, I'll multiply it by 3. So the answer to A is 3. Which is multiplied by 3. B, what is the solution to the system? So I'm going to continue based on how I started it up here. I'm going to copy down the first equation, the top equation. 4x minus 3y equals 6. And then I'm going to fully distribute into the bottom. 3 times 3x, that is 9x. 3 times 1y, that's 3y. Equals 3 times 11, that's 33. So again, the y's are going to cancel. I set that up, so I already knew it was going to happen. Adding straight down, 4x and 9x, that's 13x, equals 6 and 33, that's 39. And then we'll divide by 13 on both sides. 13's cancel. X is 3. We're almost there. We know the x value. Let's find the y value. Again, when you do this, go back to the original two equations and choose whichever one looks better to you. These are both good equations. I'm going to go with the bottom one. So we have 3x plus 1y equals 11. We have 3 times 3 plus, remember 1y is just y, so I'm going to drop the 1 and just put y equals 11. 3 times 3 is 9. Nine plus y is 11, so lastly we're going to minus 9 on both sides. Y equals 2. So my final answer is 3, 2. All right, last one. There are 180 animals in the barn. Some of the animals are chickens and some are pigs. If there are 476 legs in all, how many of each animal are there in the barn? I'll go through that again. There are 180 animals in the barn. That's a total. Some of the animals are chickens and some are pigs. That's good to know. If there are 476 legs in all, that is a hint that this is a total. How many of each animal are there in the barn? This is the question we're going to answer. So first let's define variables. We're talking about chickens and pigs, so this is pretty easy to pick from. C for chicken, P for pig. On top of that, you have to be specific. What about the chickens or the pigs? Well, this is not the kind of problem where we are selling them to other people or we're selling their meat, whatever the reason is. So there's not going to be a price attached to animals. Remember, most of the time these problems, your variables either represent a price or cost, or they represent the number of that item. In this case, we're trying to figure out how many of each animal, so how many chickens and how many pigs. In that case, we're going to call C the number of chickens. And P the number of pigs. Next, we need to make our equations. If it's not apparent to you what type of problem this is, remember we have the scenario 1 where we have the amount and the number of items equations. Usually amount refers to money equation. Or the other option is when we have two different scenarios. So usually that involves two different people or things, whatever, making multiple orders. So then you have to have an equation to model each order, if you will. So if you're not sure, you can just start with the totals and work from there. So we have 476 as one total and 180 as the other. Now for both of these, of course, you're going to have your two variables added together. So we have C plus P and C plus P. And then if you're still not sure, get specific on what the totals represent. So 476 is total number of legs. And 180 is total number of animals. Now, legs is an interesting one. When we care about how many legs are there in total, we now care about how many legs a chicken and a pig has. And right now they have a 1 in front of them. That number is not 1. So let's ask ourselves, how many legs does a chicken have? It has 2. How many legs does a pig have? Pig has 4. And then looking at the bottom equation, this is total number of animals. Remember, this is basically number of chickens plus the number of pigs is equal to 180. So chickens plus pigs should be 180 is what it's saying. So there's nothing else to add here. Again, There's not like a value or amount to attach to the C or the P. We just need to know how many of each we have. That's it. Now that my equations are set up, I can solve them. So I have 2C plus 4P equals 476. And C plus P equals 180. Now I just need to get one of these letters to cancel. So I've got 2C and then just 1C. Different numbers and different signs. Let's check out P. 4P and 1P, we have the exact same thing here. We have different numbers and the same sign, so that's not what we're wanting. So next we're just going to go with what sounds easier to do. For me, I would rather work with 2 than 4. So I'm going to multiply this bottom equation. To cancel with 2C, I want negative 2C. That's my goal. So we have negative 2C, or just negative 2, sorry. Let me rewrite that, give me a sec. Alright, I kind of fixed it. So, I want negative 2C, so I'll multiply by negative 2. And I'm going to fully distribute that into the equation. And I do have some space. So I'm going to rewrite this over here fully. So I have 2C plus 4P equals 476. And then on the bottom, I'm not going to have this new equation. Negative 2C minus 2P equals negative 360. Remember, you add the equations. 2C minus 2C, those cancel. I anticipated that. I knew that was going to happen. 4P minus 2P, that's a positive 2P, equals 476 minus 360. I just know it's negative 116, but I just have to check. Yes, positive 116. And then to solve for P, we just need to get rid of 2, so divide by 2. These cancel. P equals 116 divided by 2 is 58. Alright, we're basically done. Now we just got to find the value of C. So again, pick an equation, one of the originals, to plug P into. C will be a very quick, it will be very quick to solve C if we use the bottom equation, so that's what I'm going to do. So we have C plus P equals 180. C plus P is 58 equals 180. And then we're just going to minus 58 on both sides. C is equal to 122. Lastly, I just need to write my final answer with the labels. So I have 122 chickens and 58 pigs. And there you have it. The study guide is completed. I hope that this video was helpful. Hopefully it was able to answer as many of questions as you had. Hopefully all of your questions were answered by this. If you have any last minute questions, feel free to reach out to me via email or come see me before class starts for the test. Otherwise, I hope you have a wonderful night. Bye!